The night belongs to air freight. Despite dense fog, this Antonov 124-100 Ruslan has just landed and is taxiing to its position on the apron of Hahn Airport. The airport in the Hunsrück region is open round the clock. Its ILS Cat-3 system enabled the cargo plane to land, although the pilots couldn't see the runway until the plane was about to touch down. Ruslan is Russian for giant. The name suits it perfectly. The Antonov has a wingspan of 73 meters 30 and can transport 120,000 kilograms of freight, more than any other plane in use today. While the pilots are resting in the hotel, the Ruslan is prepared early in the morning for the next loading. Inside, the cargo hold is 36.5 meters long, 6.4 meters wide and 4.4 meters high. The freight forwarder and handling agent inspect the track system that's already been laid up the loading ramp. The boss, Georg Meyer, seizes hold of it robustly. Everything has to fit precisely. From the landing until the next takeoff, the handling agent has to be on the spot to make sure that everything runs smoothly for the plane, crew and freight. Trams can fly too, at least in an Antonov 124 Ruslan. When the nose of the plane is opened right up, the entire width and height of the loading space can be used. The tram car now being hauled into the cargo plane by the low loader is a so-called low-floor electric multiple unit from Siemens. It's bound for Hiroshima, the first of 4 combis which the Japanese have bought from the German company. 30.5 meters long, 2.5 meters wide, 3 meters 67 high and a mere 35 tons in weight, it's a real lightweight for the Antonov. Inch by inch, the tram car is towed on the rails into the plane. It'll take a whole working day for it to be in. Everything's stowed away, lashed tight and ready for takeoff. Despite all the work involved, air transport is often the best method, especially as here, when time is short and the client insists on a punctual delivery. Sea transport would take 6 to 8 weeks. Although the actual sea freight costs would be much lower, the advantages are outweighed by the high port charges, long overland routes, penalties for late delivery, and possibly the loss of the client. So air transport turns out to be cheaper after all. Depending on the destination, the cargo weight and the necessary stopovers, the transport costs are between around $200,000 and $500,000 US. Every time the giant plane lands, it costs $20,000 to $25,000. While his colleagues continue to heave the rail car on board with the help of thick steel cables and strong winches, 1 floor higher and only accessible via a steep foldable ladder, the aeroplane cook, Vladimir, is preparing lunch. Today, tomato soup is on the menu. It's already afternoon by the time the Russian loadmasters have hauled the last part of the electric multiple combi tram into the cargo hold, using chains, working with great care, inch by inch. Finally, the low loader is free and the tram has disappeared into the plane's hold. It's securely fastened on all sides. Not long afterwards, everything is ready. The ramp rises hydraulically and folds in. The nose lowers slowly. The nose is locked securely. Both the plane and the crew prepare for takeoff. Meanwhile, on the other side of the large area that makes up Hahn Airport, a second Antonov 124 plane is just being unloaded. It belongs to the Antonov Design Bureau in Kiev. The heavy-lift Volker-Kniper plane with the tram on board taxis to holding point runway 21. A total of 24 wheels carry the gigantic cargo plane. No other plane has a landing gear with so many axles. It enables the Antonov to land on and take off from uneven surfaces when there are no tarmac runways. Hahn Airport has a runway length of 11,000 feet, but the Ruslan takes off after 7,400 feet with a speed of around 135 knots. Destination Hiroshima. It will land for a stopover in the Russian town of Ulyanovsk on the Volga. The Antonov is built, inspected and repaired in the aviation workshop there. The Russian air company Volga-Dnieper, which operates 6 of the heavy cargo planes with the English Heavy Lift Company, is also located there. This is Kiev, the capital of Ukraine. This is where the Antonov Design Bureau tested and developed the mighty Antonov 124 in the 80s, solely for transporting freight, with a loading capacity of up to 150 tons when deployed for military use. The plane was seen in the West for the first time in 1985 at the Paris Le Bourget Air Show. The even larger Antonov 225, which appeared in 1989, manages a payload of almost 250 tons and has a maximum takeoff weight of 600 tons. It can carry the space shuttle Buran on its back. The Antonov 225 is actually the largest plane in the world. The Antonov Design Office has built the largest aeroplanes, but the designer has also made a name for himself with many smaller planes. The Antonov 24B, 26B and 32B are all variations of the same design, only the turboprops are different. The Antonov 32 has the most powerful engines, which give it particularly good takeoff abilities, also from hot or high-lying airfields. The Antonov 12 is a larger turboprop plane with 4 engines manufactured in huge numbers. The Antonov 24B Coke is taxiing into view here. The widely used Antonov 2 Colt looks like a Second World War plane. It has the charm of an old tractor and even sounds a bit like one. 16,000 of these multi-purpose double-deckers have been built since 1947. With its powerful 1,000 horsepower radial engine, it's become something for enthusiasts in the West. The Antonov 2 is meanwhile often used for sightseeing flights here and can be seen performing at air shows. And this is the Antonov 4, top speed 128 knots, first built in 1925. As its skis indicate, it was used to fly in ice and snow in the Russian Arctic. But back to the Antonov 124 Ruslan, which goes under the NATO codename of Condor. It's still being built today in very small numbers in Ulyanovsk, Russia, and in Kiev, Ukraine. There are currently 2 fuselage units on the Volga, one of which is in Kiev. The Antonov 124 is used throughout the world to transport extra-large and unusual cargoes. The heaviest load that ever flew was this locomotive, together with the cargo equipment weighing 146 tons. Airfoil and Antonov had already set a world record in 1993 with this power station generator, 135.2 tons. The Toyota team and its entire equipment were taken from Cologne to Nairobi to the Africa Safari Rally. 3 racing cars, 5 service trucks, a mobile workshop, 5 Land Cruisers, 200 tyres, 100 boxes with spare parts, and finally 2 Bell 206 long-range helicopters. Other remarkable cargoes include the transport round the world of America's Cup yachts, or flying a giant 200-year-old 21-metre-long cactus from Mexico to Spain for Expo 1992. A live giraffe and 588 breeding piglets have also been passengers on the Antonov 124. The cargo airlines don't just offer the flight, but also a computer-aided design for optimal loading, which makes best use of the space in the cargo hold. In order to transport the outer shell of the AN124, a 6-metre wide casing was constructed, which fitted exactly into the Antonov. A truck can pull it into the plane via the ramp lowered down from the nose. One unique feature of the Antonov 124 is that it can be stationed in a kneeling position on the nose side in order to facilitate cargo loading. When the low loader with the cargo has been unhitched and everything has been lashed securely, the truck simply drives out through the back of the plane without its trailer, through the wide open rear and down the ramp. A large number of wooden crates with election papers for the overseas territories is waiting to be loaded at London Stansted, a relatively easy cargo. In this case, forklift trucks will suffice. We're at the headquarters of Heavy Lift Cargo Airlines. Heavy Lift has been operating a joint venture with the Russian airline company Volga from Ulyanovsk since 1991. The companies jointly operate 6 Antonov 124 planes. While Heavy Lift takes care of marketing the cargo planes, the organization of the airline operation, and everything to do with its commercial running, the Russians load the planes, fly, inspect and repair them. A Russian technician opens up the folding staircase that leads up into the cockpit in order to check that everything is in order. In addition to the Antonov 124, the cargo airline operates a number of other cargo planes, including this Ilyushin IL-76. Its cargo hold is a good 20 meters long, 3.4 meters wide and 3.3 meters high. It has a maximum capacity of 45,000 kilos. 4 turbofan engines each provide a thrust of 120 kilonewton. The Shorts Belfast is a spacious transport aeroplane with a payload of almost 40 tons, powered by 4 Rolls-Royce turboprops, each with 5,730 horsepower. The offices and operations centre for Heavy Lift are located in this building, directly at London's Stansted Airport.
Good morning, can I help you?
We're allowed to go in and take a look behind the scenes of an airline that's made a special name for itself worldwide in the business of transporting cargoes of massive dimensions.
Can you just check with Vlad to make sure that's what he ordered?
I know that one definitely.
Right.
It's important that the employees here have organisational talents and a high degree of flexibility, since the aeroplanes here are not used for scheduled flights. They can only be specially booked in a so-called ad hoc charter. The client sometimes makes the order many weeks or months in advance, but sometimes just a few days or even hours before. The Russians and British work closely together. Where are the planes right now? This board shows details of numerous planes and their destinations. A red card indicates a plane is out of action for repairs. Pink means it's undergoing inspection. How does this worldwide heavy cargo business function? We're going to see this in a schematic and vastly simplified simulation. Together with Volga, Heavy Lift operates 6 Antonov 124-100 Ruslan planes. Airfoil, which is located in London Luton and is the general sales agent for the Antonov Design Bureau in Kiev, also operates 6 of the cargo giants. The planes are scattered all over the world. For example, let's say that 2 planes are at the home base in Ulyanovsk at Volga and 1 is in Kiev at the Antonov Design Bureau for repairs. The other planes are currently in Singapore, New York, Luxembourg, Mexico, Minsk, Buenos Aires, Johannesburg, Montreal, Melbourne, or are shortly to be on their way there. Siemens now places an order to transport a tram from Hahn in Germany to Hiroshima in Japan. A cargo of textiles has to go from Colombo in Sri Lanka via Karachi to London Stansted. MiG-29s have to go from Minsk in Belarus to Lima in Peru. Telecommunications equipment has to go from Stockholm to Shanghai in China. If a cargo airline has an Antonov near the required loading airport or is shortly expecting one to land there, then of course it'll want to use this plane for the new order. So the plane in Minsk flies to Lima. The one in Luxembourg is directed to fly to Hahn and from there flies on to Hiroshima. It would now be ideal if this plane could also execute the order in Colombo, Sri Lanka, and take the cargo of textiles via Karachi to Stansted. If the plane cannot continue after Hiroshima, then the Antonov in Melbourne would be next in line. Certainly the distance from Stansted to Stockholm would not be very great, and from there the new destination would be Shanghai. It's important that some planes stay in the American sphere so that they can be put into operation quickly from there. Each cargo giant is always accompanied on its journeys around the world by a British flight manager. This means that he's often with the crew for weeks at a time. Flight manager Robert is just coming out of the Heavy Lift building in Stansted. We follow him to Cologne. When we arrive there, it's already evening. An Antonov 124 Ruslan is already waiting, its nose and rear doors wide open for loading. The workers are used to the nerve-wracking warning signal. It always sounds when the stairs leading up to the top floor are opened up and the cockpit hatch is not closed. The loading crew works flat out to prepare the plane for its new cargo, laying out the ramps and rails. They have to be ready by tonight. Takeoff is scheduled for 7 o'clock in the morning. The cargo, car presses for Ford in Detroit, is expected punctually, but first it's necessary to carry out some work in the rear of the plane. Cargo equipment has to be shunted. The Antonov is not reliant on any loading equipment at the airport, using its own overhead cranes travelling the length of the interior and 2 hoists travelling across the width. Loads of up to 37 tons can be lifted and moved. At the nose of the plane, the loadmasters are meanwhile concentrating on attaching the heavy cargo to the crane. Each one of these special thick cables can carry 30,000 kilos. They are making good progress laying the rails. Several different loading systems, designed to carry extremely heavy weights and adaptable to the individual demands, have been specially designed for the Ruslan. The cargo will soon be pulled easily into the aircraft hold via these roller elements. Setting down the load demands precision work. Every inch counts. Plywood planks which the loaders push between the pulling chains and the rails help the chains to slide more easily and at the same time protect the material. Guide pulleys capable of carrying extremely heavy loads and strong motor-driven winches certainly help to move this 75-ton machine. But sometimes pure manpower is needed, for example when the pulley has to be re-anchored further back. Shortly before dawn, the job is complete. The cargo and the rails are inside, the ramp has been raised and folded in. The nose can close. At the very tip of the nose sits the radar. With more than 65 tons of cargo on board, the Antonov can only be fueled when it's no longer in the kneeling position. Otherwise, it wouldn't be able to get up again. Depending on the amount needed, fueling the plane from tankers can take up to 2 to 3 hours. If ground tanks are used, the process is faster. The Ruslan is filled with 121,110 kilos of kerosene for this trip. It's been calculated it will use 88,480 kilos by the time it makes its stopover in Gander. The rest is the stipulated reserve, and an extra 10 tons for the expected bad weather conditions. Just for taxiing at Cologne Airport, it'll need 3,000 kilos of fuel. A pushback is required. The cargo giant has its own huge push bar, usually stowed in the rear. It alone weighs 1.5 tons. After the pushback, the push bar is loaded into the rear again. The Antonov 124 taxis towards its starting position. Its 382-ton takeoff weight means that it's 10 tons below its normal civil maximum takeoff weight of 392 tons. The 4 Latarov D18T turbofan engines, each with 230 kilonewton static thrust, can easily bring the Colossus to its necessary liftoff speed of around 140 knots. Change of scene. A Ruslan operated by airfoil from the Antonov Design Bureau in Kiev is standing in Prague. After many years of tough negotiations, the British cargo airline succeeded in 1989 in getting the first Antonov 124 for commercial charter flights in the West. In the same year, Airfoil became general sales agent. The British company have been representing the Ukrainian aircraft manufacturer worldwide since 1993. Along with the 6 Antonov 124-100 planes, Airfoil also uses the smaller cargo planes Antonov 22 and Antonov 12. In July 1999, Airfoil and the Antonov Design Bureau celebrated 10 years of successful partnership. Here in Prague, a giant 2-part power station turbine casing from Skoda is being loaded. It's bound for General Electric in the USA. Together with its equipment, the cargo weighs 122,990 kilos, which is more than the permitted maximum payload of 120 tons normally used in civil operations. However, the designer in Kiev can grant a special permit in such cases. This cargo also requires a loading system which is unknown to us. The floor of the cargo hold has not been covered with planks in this case. It's made of pure titanium, originally designed to take other heavy pieces, such as tanks. Along the right and left walls of the cargo hold are large volume hydraulic reservoirs which can be read easily. This is the hydraulic system for the landing gear. The main landing gear consists on each side of 5 axles, each with 2 wheels, making 20 wheels in total. The nose landing gear also has 2 axles, and on each side 2 wheels carry the weight. The upper part of the turbine casing is now set down on the metal pallet. Then both can be pulled together into the cargo hold. This time, we'll accompany the cargo on its journey to America. We hope that we shall be allowed into the cockpit. No film crew has ever before been allowed to be present here during the flight, but we haven't reached that stage yet. First, everything has to be loaded.
Сергей, уберите вот эти вот балки, которые лежат впереди.
Clear away the beam in the front, orders Anatoly to his colleague Sergei. Anatoly is operating the controls for the winches, which seem to be hauling in the 123 tons effortlessly. The cargo has arrived at its preset position, and while it's being firmly anchored with strong chains, the technical flight manager, Vadim Deniskov, checks the weight and balance. Is the load really in the right position? He can establish this with the aid of the figures on the sideboards. Then he goes through everything carefully again. He makes a center of gravity calculation and comes to the conclusion that the load ought to be moved a few centimeters further back. An error in the weight and balance could have fatal results. The plane would have difficult or even unpredictable characteristics, which would become especially and unpleasantly obvious during takeoff and landing. Detailed plans for the loading procedure were drawn up with the aid of computers some time ago. Very slowly, the Ruslan rises from its kneeling position with the help of the hydraulic system. Although the plane has not yet been fueled, more than 320 tons now have to be raised, adding together dry operating weight, cargo, and the fuel still in the tanks. We also want to take a close look at how the nose is lowered and closed. It's not always easy to release the brake chocks. Then the fuel trucks arrive. Since the next refueling stop will be in Shannon, Ireland, just 2.5 hours away, the plane obviously doesn't need to be completely fueled. 17 to 19 tons of fuel need to be calculated for the first flight hour. During the climb, depending on the weight of the cargo. 13 to 14 tons have been calculated for the second hour after takeoff. Then, if it's heavy, the Antonov will use another 13 tons for cruising at an altitude of 33,000 feet. If it's light, it will use 8 tons. The descent and landing will require 11 tons per hour. The Ruslan is fueled from both sides simultaneously with a pressure of 50 psi, pounds per square inch, per fuel hose. The technician can steer the kerosene into the individual tanks with the aid of the fuel distribution valves. The aeroplane has 14 tanks in all. Meanwhile, the flight deck crew have been picked up from their hotel where they've been resting since 1 a.m. the previous night. The crew's made up of 8 men, 3 pilots, 2 flight engineers, 2 navigators and a radio operator. This is more than usual. Normally the crew is made up of 6 to 7 people, but today a Czech pilot is flying as well, because the first officer is hoping to become captain of the Ruslan and he still has to pass a Czech flight. Here he is, coming up the steep stairs to the cockpit, Konstantin Kalugin, until now first officer on the Antonov 124. He goes straight through to the front to the pilot flying seat. And this is Bob Pravoncha, the British flight manager, who will be accompanying this trip. Meanwhile, First Officer Konstantin has changed and is beginning his check of the giant aircraft. He checks the landing gear and tyres particularly thoroughly. Are there any cracks? Is everything closed? Are there any leaks? Are all the markings in the correct positions? But he also takes a look at the engines and the pitot tube. After a short while, the Antonov is ready to start taxiing. Takeoff is planned for 2000 hours local time. All the crew members are very busy with flight preparations. Pilot in command, Anatoly Krustitsky, is sitting in the co-pilot seat. Radio operator Andrei receives permission to take off and pilot Konstantin pushes the throttles for the 4 engines slowly forward. But then the takeoff is aborted. The pilots have spotted an error on the display for the airspeed indicator. As later becomes clear, the problem lies with the electronic transfer of data from the pitot static system. The Ruslan taxis back again. The Antonov technicians can check many of the plane's systems themselves and install spare parts where necessary. Wherever the Antonov 124 lands, the crew is able to carry out the inspection work and repairs, which is why it carries an extensive supply of spare parts. By the time the Antonov can finally take off, it's 1 o'clock in the morning.
Delta Bravo 4197, clear for takeoff runway 31, speed 2806 knots, airborne frequency 121.4, goodbye.
Taking off, goodbye, airborne frequency 1214, Delta Bravo 4197.
When we've left Prague, destination Shannon, Ireland, the light in the cockpit may be switched on again. All the instruments are working perfectly. The instruments in the Antonov 124-100 Ruslan cockpit are still mainly analog. Right now, we're passing flight level 140. Flight engineer Vitali starts to switch the fuel pumps. We are quickly 5,000 feet higher, climb further, and begin to turn right. Now the aircraft is level again. Directly in front of the throttles are the indicators showing how the engines are functioning. The airspeed indicators are directly in front of the pilot. At the top is the speed in Mach numbers. At the moment, as we climb, just Mach 0.62. The white indicator shows the airspeed in kilometers. The red and yellow stripe one shows the maximum speed in relation to the altitude. This instrument is largely unknown in Western civil planes. On the left, it shows the angle of attack, that is, the angle to the direction of the relative wind, and helps to steer the plane very safely. Navigator Yevgeny is just setting the intersection point Saski on his GPS, 324 nautical miles away. The course to this point is 287 degrees. In addition, he has almost every imaginable navigation aid: Doppler radar, inertial navigation system, INS, LORAN, Omega, and of course VOR, DME, and ADF. He could even operate celestial navigation as well. Here, he has set the DME frequency. Radio operator Andrei is looking for the approach frequency for Shannon. He also has an altimeter, but his shows the altitude in meters, not feet. To the left of his workplace are short and medium wave transmitters and receivers. He enters the frequencies on a numerical keyboard. We are now passing flight level 290 and will shortly reach our allotted altitude of 31,000 feet. These are the flight engineers' workplaces. On the right are the electronics with numerous backup circuits. In the middle is the air conditioning with all the regulators for temperature and the cabin pressure, the hydraulics. And on the left, the engine monitoring instruments. Further to the left are the pumps for fuel management. Monitoring the engines is one of the most important duties of the flight engineer. Here on the right is the temperature indicator, which has to be multiplied by 100, and on the left is the engine speed as a percentage. On the outer right side, we can see the vibration control. The flight engineer notes all the important flight data in his book. This screen shows all the different temperature areas in the aircraft. The temperature and air pressure can be individually regulated in the cockpit, crew cabin and cargo hold. However, the cargo hold is not pressure ventilated. These two VOR displays allow the navigator to read the distance in kilometers instead of nautical miles, as is usual in Western aircraft. Here are the switches for setting the Doppler radar.
Alpha Delta Bravo 41907, you're clear Gander Airport, visual approach on my 22. Okay, Alpha Delta Bravo 41907, стоят visual approach on my 22. Оценочка нажали. 250. Roger, Gander Tower on 118. Go get it out.
We're now making our approach to Shannon in Ireland. The two pilots are studying the approach charts again and are holding the approach briefing.
Alpha Delta Bravo 4197, Gander Tower, good morning, runway 22, winds 280 at 7 knots, altimeter 3005, your number 1, clear to land, runway 22. 4197, clear to land, altimeter 3005.
We've received clearance to land. Constantine switches off the autopilot. Immediately after the landing, the technicians come up into the flight deck, stand behind the crew and watch to see that all the equipment and instruments are working perfectly. There's a specialist for each system. Altogether, 11 technicians are on board. Meanwhile, the second navigator, Mikola, has taken over from his colleague and is preparing for the next leg of the journey. The technicians leave the cockpit and go back to their crew room at the rear of the aircraft. Behind them, the hatch is locked firmly again. After starting our journey in Prague and crossing Europe in a northwesterly direction, we've now made a refueling stop in Shannon. Originally, the journey from here onwards was to have continued over Keflavik in Iceland for refueling, and from there on to Gander in Newfoundland. But because of the time lost in Prague, the crew decides to put more kerosene in the tanks and fly direct to Gander. From there, the next stop will be Stewart Field near New York, and then we'll go on to Houston in Texas. With the larger quantity of fuel, 90 tons, we now have a takeoff weight totaling 405 tons, the maximum takeoff weight for military use. Only 392 tons are normally allowed in civil use. The Antonov Design Bureau has granted a special permit. The flight engineer has just finished the first fuel check. He reads off the fuel used so far, compares it with what's left and distributes it equally. There are 4 groups of fuel pumps. If a group shuts down, it can be replaced by another. These barometric instruments are used to regulate the cabin pressure depending on the respective outside air pressure. The senior pilot and first officer have changed places. Constantine is now sitting in the co-pilot seat. The large dark red knob between the two men is the rudder trim. The trim wheel next to it serves the trim around the longitudinal axis of the aircraft. Captain Anatoly stands up and goes for a short break in the pilot's crew room. Of course, the plane can also be flown from the right-hand seat. The radio operator doesn't have much to do over the Atlantic at the moment either, and allows himself a little nap. Outside, it's gradually getting light. Time to have a closer look at this yellow lever. It initiates the reverse thrust. This lowers the slats to an angle of 60 degrees. This lever on the right is for the main flaps. The flaps are set at each takeoff and landing and facilitate the lift so the plane can fly more slowly. These are the controls for the autopilot. We are already making our approach to Gander. The pilot reduces speed. Unfortunately, it's dark outside, so we can't follow the landing precisely. After landing, the technicians come into the cockpit again to check all the systems. Numerous switches have to be changed, and a large number of the circuit breakers are pulled. Gander in Newfoundland was built in 1959 and used to be a hub of activity. All the planes that wanted to cross the Atlantic made a refueling stop here. Today, the modern long-range passenger aircraft manage without an intermediary stop. Today, it's mainly the heavily loaded cargo planes and the smaller passenger planes that meet here. Bob has already gone to Gander Flight Support to get all the important data for our ongoing flight.
Okay, Bob, this is your flight plan. And your time en route is 2 hours and 43 minutes.
Okay.
And the showing for a fuel of 53,870, plus 2,600 for taxi.
Okay, we're being refueled now, is that right?
Yeah, the fuel is on the way there now.
Okay, good.
They're using New York for an alternate. You want that changed to Newark,
I'd like
yeah?
to change that to Newark.
Okay, I'll follow this now and change it to Newark, flight plan. Up to 1,200, the wind is 250 at 5 knots, visibility 6+. Scattered at 4,000 and broken at 7,000. Up to 13, and after 1,300, your alternate, we're going to use Newark. Newark. After 1,200, the wind is 270 at 10 knots, visibility 6+. From 0800 until you arrive near 12, the forecast, the wind is 250 at 5 knots, visibility 6+, scattered at 4,000, broken at 7,000. And after 1,300 Zulu...
Bill provides us with the weather forecast for our destination airport and the alternate airport. We'll have very good visibility. No problems for takeoff in 1 hour or for landing. While the Ruslan is being refueled, the sun gradually rises over Gander. It's calculated that we'll use 38,480 kilos of kerosene for the next 1,000 nautical miles until Stewart Airfield. We'll fill up with 53,870 kilograms, including fuel for the reserve and for taxiing. Meanwhile, the technicians check the engines, inspect the lines, and, if necessary, top up the oil. Then the crew starts its preparations for takeoff. In the meantime, we'll take a look at the avionics department, which is situated behind the cockpit. There are thick bundles of cables here. This is the heart of the aeroplane. Gyroscopic instruments, autopilot, radar equipment, all the avionic equipment, flight computer and air conditioning are all found here. The technicians take a final look at all the instruments before takeoff.
After Gander 3 departure, direct tops, direct Bangor, flight plan route.
After Gander 3, direct tops, direct Bangor, Zone 4197, request for up runway 22.
Zone Bravo 4197, Tower taxi to position, runway 22, I check 4 minutes in position. Advise ready for departure, tower frequency 118.1.
Roger, 118.1, thank you.
Alpha Delta Bravo 4197, roger sir, I checked that, and check you just blocked out a complete Oceanic readback. Winds are 270 at 5 knots, contact Gator Center at 132.1, cleared for takeoff, runway 22.
Cannot runway 22, I'm sorry for what, Alpha Delta Bravo 4197, goodbye.
Good day. After 51, 50 north, 51 north, 50 west, I missed it all, why don't you try it again?
Норма. Номинал норма.
Взлетный режим.
Скорость растет. Параметры взлетного норма. 150. 170.
31705, roger, readback is correct. No anticipated with clearance. Start your discretion advisory.
230. Параметры нормы.
Один. Все, положение пошел.
260. 270.
Шасси убрать.
Высота более 10. 290. Шасси набирается.
Dispatch to 300. Yeah, you want to go on runway 22? 22 Alpha, the headroom.
262 выбранных створки закрыты, можно.
Нейтрально. Курс какой?
When the plane has reached about 800 feet, the senior pilot instructs his co-pilot to retract the landing gear.
Maintain flight level 280. Alpha Delta Bravo 4180. Так, не дергай, сама спокойно. Ладненько, просто выделяем.
Отходим в курсу.
Senior pilot Anatoly is flying the first leg of the journey after takeoff from Gander. The Czech pilot, Volodymyr Kulikov, has taken over the co-pilot's duties. Then First Officer Constantine's check continues. The Czech pilot sits next to him. Although he looks rather critical, there's nothing to complain about. There are about 50 Antonov 124s currently in military and civil use. A maximum of 200 pilots worldwide are authorized to fly the civil version, the Antonov 124-100. When the plane has reached its cruising altitude of around 30,000 feet, as here, the Antonov 124 attains a speed of approximately 460 knots. The flight managers, Bob and Vadim, have been waging a constant battle in the crew cabin against the endless mountain of paper. They've hardly had any sleep for days. We want to know more about their duties.
I'd be happy to. Actually, I'm the airfoil flight manager. This is Vadim, he's the Antonov Design Bureau flight manager. Together, when the aircraft is chartered by my company, we fly together, and our role is more or less to facilitate the cargo being loaded and facilitate it getting through the sequence of flights to its final destination. That involves, as you've seen, very many things, sometimes a fair amount of difficulties, but it's our job to make sure that we serve the customer, get the cargo to its destination, and try to get it there on time. That's more or less the job.
originally at aircraft there are two responsible people for balance of aircraft. They are loadmaster and co-pilot. But flight manager is responsible for all stuff the aircraft, and also he is responsible for correct weight and balance, and he helps to these two persons to get this good decision.
Well, the main job is actually also to pay the bills to for the aircraft, make sure the flight plans get filed. I can liaise with a customer if there are any problems, which sometimes is a problem in itself, because as you know and as you've seen, there are many foreign countries involved. I don't speak so many languages, and sometimes it's a bit difficult. But we engage handling companies to help us in that task at the various airports around the world. And in spite of itself, it tends to work reasonably well.
Indeed, the flight managers succeed time and again in delivering their cargo to its destination. We're making our descent again with 1,000 to 1,500 feet per minute. The captain adjusts the throttles and secures them with the friction lock. We quickly break through the thin cloud cover. Captain Anatoly lowers the landing gear at an altitude of 3,700 feet, around 13 nautical miles before touchdown. On finals, we have a speed of 160 knots. The flaps are set at 30 degrees. The giant aircraft gently touches down at Stewart Airfield in New York State at 105 knots. Lifting the reverse thrust lever and then pulling it back requires quite a lot of strength. A great many American Lockheed Galaxy military aircraft are stationed here at Stewart Airfield. This transport plane, first used in 1966, bears an unmistakable resemblance to the Antonov 124. After his check flight, we asked the brand new captain which planes he had already flown.
All type of aircraft of Antonov Design Bureau and another aircraft, and Tupolev, Ilyushin, and Mikoyan, and another, and Bereev, and another. I'm the pilot since 1969. I was a military pilot. How military pilot I was flew since 1970.
The loadmasters and the technicians invited us to come with them into their rest and living area. This is where the team sits, eats and sleeps when the plane is flying. However, we're not allowed into the sleeping quarters. The globe balloon is not just for decoration. If there were to be a serious loss of pressure in the cabin, the air inside it would expand considerably. With this picture, the crew honors the memory of the famous aircraft engineer Oleg Antonov, who died in 1984. In a record flight in 1988, the Antonov 124 stayed in the air for a total of 25 hours without cargo, but fueled to the brim. It had a takeoff weight of 430 tons and flew a distance of 9,700 miles. The fuel had been drastically cooled in order to make it thicker. It required a runway length of 16,000 feet in order to take off. As soon as the nose has been raised again, the unloading process can begin. The power station turbine cases for General Electric have now reached their destination. We can now watch the Ruslan's unique ability to kneel down. These controls are used to lower and fold out the loading ramp hydraulically. They can also lift the nose or bring the plane to its knees. The adjustable platforms are used to bring the ramp to the correct height for transferring the cargo to the waiting truck. Over at the Galaxy, a plane is just opening up its nose, but the Galaxy is somewhat smaller than the Antonov 124, has weaker engines, and can transport a payload of about 25 tons less. The platforms have now been set up and unloading can commence. Just as with the loading process, unloading this unusual cargo takes several hours. Again, precision work is required. It took a whole day before the Antonov was able to take off for its next destination, Houston in Texas, and it's the middle of the night again. Strong whirlwinds forced us to postpone takeoff several times. We've now been airborne for 4 hours. In a few days, the Ruslan will head for Brindisi in Italy with a new cargo. And we say farewell to a crew that, despite all the language difficulties, gave us a warm and friendly welcome on board their aircraft.
0 реверс. Ноль. Держим. Обогревы выключаем. Пары малой.